couple of final quick topics from this section. One dealing with graphing given an ordered pair and a slope rather than the slope and the y-intercept, and then trying to come up with the equation of the line from the graph. So this is actually a nice useful thing that we can do here. So what we can do, if we're given a slope and an ordered pair, we can just plot the ordered pair first, right? Makes sense. And then use the rise over run definition to move to the next point, and so on and so forth. So if we're asked to draw the graph of the line passing through -3, -5, having a slope of 3, well, the first thing we want to do really is identify that the slope of 3 really means 3 over 1. So this means that we're going to move up 3 and over 1. The difference here is instead of starting at a y-intercept, we're actually going to start at the point they give us. So we're going to start here at -3, -5, which would be 3 left and 5 down. And then from there, we're going to move up 3 over 1 and plot a point. We're going to move up 3 over 1, plot another point. Up 3 over 1, plot another point. And that's all the nice points that we can plot on this particular line on this from the grid that we're given. And then we'll just go and graph it. So there's our line. Goes through -3, -5, and it has a slope of 3. But now the other thing that you should notice here is that we can do, which is beautiful, now that we've actually graphed the line, we can see that this has a y-intercept of 4. Okay, so we can actually write the equation of the line. We knew the slope was 3, and now from the graph we can see that the y-intercept is 4. So we know the equation is just y equals 3x plus 4. All right, so that one worked out nicely because the y-intercept ended up exactly at an integer value, which we plotted on the graph of 4. Now the problem is that might not always happen. Okay, so let's say we have a similar scenario where we have a point and a slope, right? Slope of -1/3, which means we're going to move down 1 and over 3. But now we're going to start at -5, 3. So we're going to start at -5, 3, which is left 5 and up 3. And then we're going to move 1 down and over 3. Plot a point. 1 down and over 3. Plot another point. 1 down and over 3. Plot another point. And now we can graph. So we connected, but now the problem with this line is we can't tell what the y-intercept is, right? It doesn't land exactly at an integer value. It's somewhere between 1 and 2, but we can't find it exactly. So what we can do is we can just use that little technique that we had used previously to find the equation of a line. We can just write y equals mx plus b. We're trying to find b, but we know the slope is -1/3. So we replace m with -1/3. And now we can use any of these 1, 2, 3, 4 points we have to plug in for x and y. So let's say we use 4, 0, that x-intercept, right? Plug in 4 for x, 0 for y, and now just solve for b. So -1/3 times 4 is going to be -4/3 plus b equals 0. And then all we'd have to do now is add 4/3 to both sides. And there's our b value. So b is just going to be 4/3. So now we can put the slope, which was -1/3, together with the y-intercept, which was 4/3, and write the equation, which is just y equals -1/3 x plus 4/3. And you can see from the graph, does 4/3 make sense? Yeah, because 4/3 is really 1 and 1/3, and it looks like that is 1 and 1/3, right? It's definitely between 1 and 2, and it looks like it's a little bit closer to 1, so 1 and 1/3 actually makes sense there. And then just one final thing covered in this section is this whole idea of parallel lines. And what parallel lines are lines that never intersect. So basically they stay the same distance apart at all times, which means they're actually going to have equal slopes. Okay, so if any lines that don't have equal slopes are going to eventually cross somewhere, the only time they're never going to cross is if they have equal slopes. So parallel lines are going to have equal slopes. So if we're given a question like this, sketch the graph of the line that's parallel to 2y plus x equals 8 and passes through the point negative 2, 2, and then write the equation of the line. Well, I know it's parallel to 2y plus x equals 8, which means it has the same slope as this line. So let's find out what the slope of this line is by putting it into our y equals mx plus b form. So we'd subtract x, and then we divide by 2. So once we do this, the equation of this other line ends up being negative x over 2 is really negative 1/2 x plus 4. So the slope is negative 1/2. So the slope of the line that we're going to graph is also negative 1/2, right? Because they have equal slopes. Now, do we know what the y-intercept is yet? No, but we do know it passes through negative 2, 2. So we're going to start here at negative 2, 2, and then we're going to move down 1 and write 2 from there. So if we start at negative 2, 2, and we move down 1 and write 2, 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 there's our line, which we'll now graph. So we graphed it, and now we should be able to see from the graph, this is again one of those nice cases where we got the y-intercept as a nice integer value of 1. So now we knew the slope was negative 1/2 and the y-intercept was 1. So the equation of that line is just going to be y equals negative 1/2 x plus 1. And then you can see when you compare that line that we got the equation of with the original line, yes, it makes sense that they're parallel, right? Because they have same slope but different y-intercepts, which means they're parallel.